Morning. We are here today, so we want to speak about an architectural partner, which is MVI, and what we want to show you is how not to look the internet about this pattern. So first of all, some presentations. I'm Matteo, nice to meet you. I'm a mobile architect and an iOS developer. This is my colleague Massimo.
Hello, everybody.
Okay. Okay, perfect. So, why we are here today? Today we are here because, as we just said, we want to show you what we found difficult adopting this architectural pattern in the mobile environment. Oh, question: how many mobile developers are here today? Okay, great, fine, perfect. So what we want to show you is the difficulties that we found out implementing this architectural pattern, and which are the possible missing crucial points that we found in literature and in the different articles that are on the internet. So the talk is divided into two parts. The first one that I'm talking about is the theory part, the boring part. I'm showing you what is and why and which are the crucial points, the key points of the model view intent architectural pattern. Massimo will show you something more crunchy, which is the code, and we show you the actual implementation that is in production in our app. So what we want to show you is that this can be used. Okay, so let's go on. Okay, some theory. Why and why, and what is it, and when we should use it. Okay, let's start from some history. So it is inspired by a web framework, which is Cycle.js, and it is a unidirectional, sorry, and cyclical framework for web development, of course. And the first crucial point is the unidirectional data flow. So as you can see from the image, the arrows simply goes only in one way. And if you can think about other M patterns like model view model or model view controller or model view presenter, model whatever you want, there is always a bidirectional communication, a bidirectional. Can you hear me? Like this? Okay, perfect. There is a bidirectional data flow. So the first main difference is this. The data flow is unidirectional, and each single piece of the architectural pattern communicate in one way, only in one way. Okay. So why this is important? This is important for the principle of the single source of truth and to maintain data correct. One of the main, we can say, errors that we found out using, or problems, not errors, but problems we found out with, for example, model, VV model, is the consistency of the data. Because, again, based on the fact that the data is connected in two ways, sometimes there is there are some problems related to the maintenance of the single source of truth. Well, you can understand that this particularly fits with the declarative UI framework, like Jetpack Compose, Swift UI, or Flutter as well. So in this situation, we can understand that the MVI is perfect for these frameworks, and totally fits also because it's totally involved, or I mean, it's connected. The passage of the data is connected with the reactive programming. Let's go on, and let's see each piece of the blocks that are composing the MVI architecture. Let's start from probably the most difficult one. So the intents. What are intents? Intents are not the Android or iOS intents. Intents, we can think about intents as user intentions, user desire, and they are the instrument by which we can translate the user mental model to the app, the project business model. So it is the connection, the piece, call it whatever you want, but it is translating the user interaction to something which is model friendly with our business logic. I want to stress about this thing because this topic, this part, because for us it was pretty hard to understand. So don't think about intents just like tap gestures, swipes, or a simple click on the UI. It is something like, okay, as a user, I want to execute a login. I want to execute a login, and what does it mean for our business logic? For our business logic, should be translated as, okay, I want to retrieve retrieve a valid session, save something on a database, communicate with my backend, and so on. So the intent translates what the user wants and desire to our business logic. That's one. And let's talk about the model. Okay, so what is representing the model? The model is representing, again, our business logic and the global state of the app. Okay, so you can imagine the division into different modules, which each one has a model, and the global states represented the entire state of the app. So it encapsulates also the business logic. So let's think about, again, everything which is related, for example, to communicate with our databases, local or remotely, and so on, and all it handles the state of the app and do all the operations useful to change the state of the app. So again, we have the security of the single source of truth, because the model receives an input, an intention, a desire of the user, receive this intent and change its state accordingly to this intent. Different intents will change the state of the model in different ways. Think about it as a pure function. Do you know pure function? Yes, no, yes, okay. So pure function, with an input, there will be always the same result. And the model is pretty much the same with the inputs. So the model again changes its state in function of an input. Let's go on. Finally, we have the last block, or the last two blocks, the view and the state. So what is the view? The view is what we are seeing on the screen, our layout. Our layout, which is observing the model state, which is changed with the intents, and the view is rendering itself based on the state that is emitted from the model. So again, the view is in function of the model state. Different rendering are done with different states emitted by the model. And the fact, again, that the state is immutable, we can figure out that is perfect, because on every single state we have a particular layout for what we want. But the state, what is the state? The state is all the set of information that we should have to correctly populate or correctly display data on the screen, on the view. Well, you can understand that, again, like we said at the beginning, this is perfectly fitting with the declarative UI. So think about Jetpack Compose or Swift UI, where we are just thinking about what we are representing and not how, like in imperative frameworks. So it is totally a match. Let's go on. So to sum up, we saw that the main difference between the other M patterns from MVI is the unidirectional data flow. That image is particularly important because we can understand that the user has a desire and express this with the intent. The model changes its state based in function of the intent, of the intents. And then the view is changing itself, rendering itself in function of the state emitted by the model. And again, it's particularly a match for the Jetpack Compose, Flutter, or Swift UI frameworks, for declarative frameworks that want only to concern about what we are displaying without carrying on about how we are displaying the data. Let's go on with Massimo, which is showing you something more important.
Okay, thank you, Matteo. So hello again, everybody. Now I'm going to show you how we actually implemented our idea of MVI in an Android Kotlin library. First, I want to mention my colleague and friend, Giovanni Donato, who's actually the author of this library. I'm just a collaborator that arrived too late to the party, but I'm here presenting to you the idea. So I'm gonna show you how our library works with a simple example. Here we have simple app with 2 input fields and 2 buttons. The user wants to type 1 number in each input field. And then with the button sum, he wants to find out the result of the sum, and with the button save sum, save the result of the sum somewhere on a DB, or I don't know. So those were the intentions of the user, like Matteo explained to you. And here we actually we declare this intention in our code with a sealed interface for type checking in Kotlin. And we extend intent, which is part of our library. And we have 4 different intentions. I just mentioned them. There's a difference here. There's data class, which is actually taking an input of the user. And then there's object sum or object save sum, which doesn't need an input. So it's a simple object. What is an interface? What is an intent? I hope you know what the interface is. In our library, an intent is just a marker useful for type checking. Let's continue declaring the state. So here in the state, we are declaring some informations that are going to be useful to render the UI. Or in the case of the sum, to store it on some DB. So we have the first number, second number, we've seen these names already, and the sum, the result of the sum. State is only one, and it's held by the store. I'm going to talk about what is the store soon. And well, let's say for a moment that we have a layered structure, layered architecture. We have like a data domain layer. So the model communicates with the domain layer to get some data, okay? We can actually have a state model to store all this data we're getting from these calls. And then the state is mapped in the UI state. So it sounds like we have 2 states, but actually it's 1, because we're from 1 state, we're retrieving the state of the UI. This is for separation of concerns. So again, the UI state is calculated based on the state of the model. State, again, just a marker. And you have to be careful because the state has to be immutable. Otherwise, we can find ourselves in a situation where we create a mutable state and the library won't actually react to the change of the state. So that might be a problem. How do we update the state then? With the reducers. Reducers are pure functions. Matteo explains what it is, but let me say one more time. A pure function is a function that, given an input, it returns a result. And no matter how many times you call this function, if you pass the same input, it's always going to give out the same result. So it's deterministic. And this is the signature of the reducer in our library. The function reduce is a pure function. You see, it takes a state and returns a state. So here we define our sum reducers factory. We have 3 different reducers. Each reducer to update part of our state. We take an input, for example, for the update first number and same for second number, and we return a reducer based on the state, which is sum state. We saw it earlier. Here is the actual implementation of our reducer factory. For example, for update first number, we take an input and we declare the reducer based on sum state, which gives us the current state, which is S. And on S, on the current state, we call the function copy, so that we can assign the inputs to the first number, for example. This is how we update the states with our reducers. And it's different, for example, for update sum, because we don't have any inputs. So we calculate the sum with the data in our state. We just call S first number plus S second number. That's it. We did our sum. So the reducer factory is just an abstraction on reducer that we're using to try to divide as much as possible the state update logic from the model. So you don't have to do this. This is just our way to implement things, and I think it's best to keep them separated. And we use high-order functions, which are functions that take an input another function and or return another function. I said functions too many times, but yeah. Let's see what's next. We're going to see who is holding the states. I talked it before, the store. This is the store in our library. It has 3 properties: current state, which is based on state, a flow of states, and a function update that takes an input reducer based on S, on state, and it returns the state. So the store holds the state. And here in the function update, we pass the reducer function so that the store can create the new updated state. Lower, we see the function store, which is the public function that we're going to use in our model to actually store the state. Next, we're going to see finally the model where everything gets connected. Wrong model, sorry. Here is the model in our library. It's a fine interface based on state and intent. The model exposes the function subscriber to, which takes an input flow of intents, and it returns a flow of states. Why is it a flow of intents? Well, so that it can handle operations that involve multiple intents even at the same time. For example, a call with debounce. We use flow. I hope you know what the flow is in Kotlin, because it's the actual reactive components that is given by Kotlin. And it's useful, as you know, to handle a synchronous stream of events. And the function is called subscribe to because it actually subscribes to the flow of events given by the UI. We're going to see this pretty soon. We declare our sum model, which extends model based on some state, some intent. We declare a couple variables, reducers, we just declare them, and a repository, which is we're going to use to save our sum remotely or on some local DB. Here we override the function subscribe to, and we call this other function, which is part of our library. It's called state machine. What is a state machine? Let me explain it with a simple example. There's a switch button. It can be in two different states, on and off. And to go from one state to the other, we draw this line, which is actually the reducer, because what it does, it's updating our states. And this arrow, this reducer is based on an intent. When we want to switch off the button, we go from on to off. That's our intent. And we reduce the state. We create a new state. We update our state. So, but theoretically, what is a state machine? A state machine represents an abstract machine that can be in exactly one of a finite number of states at any given time. And we need this concept of the state machine to formalize the deterministic property of the state of the model. This was a bit hard. I get it. Let's continue. We have, let's see actually how it works. What are we doing here in our model? Well, we have this keyword on from our library. You give it the intent that you want to react to. What do we do once we're reacting to this intent? What do? We want to, after the user inputs a number, we want to update the state so that we save that number that the user is typing. And update state, that function, it takes an input, another function, which is our reducer. We saw it earlier. So we call reducer factory, update first number, and we update state also gives us the intents. And from the intent that we see in data class at first, we can get the number. That's the number that the user is inputting. And then we can pass to the reducer, so we can update our states. Similar scenario for same thing for type second number. It's not written here, but same exact thing. For sum, well, there's no inputs, so we can just call this infix function update states reducer factory update sum. There we go. Whenever the user press the button sum, we react to that and we update the sum. We calculate the sum. Okay, there's a different scenario here. On save sum, we use this keyword called side effect. Side effect is an opposite function of a pure function. It's a non-deterministic function. For example, a network call. Well, when we do a network call, hopefully we get a 200, a success, but sometimes we get an error. And that's a side effect because it's non-deterministic. It's not always happening. So yeah, we call side effect here for our save sum, which is actually there's a mistake here. it's not a reducer factory. It's the repository that's calling that function. Oops, mistake. But yeah, so it's we're calling the function from the repository to save the sum on some DB, and we pass we get the sum from the current state. Also, in the scope of side effects, even if, because here we can actually also update the state. It's okay, we can do that. But if we do update the state, then whenever we call current state in the same scope of side effect, we're still getting the latest update state. Last thing about side effects is here is where we want to call suspend functions. Here is just a recap of the model. And one last important thing about model is that model is immutable. So every function or variable that we declare inside a scope should only be called in subscribe to. This is to prevent an inconsistent state, because if I use a variable, a mutable variable like a var, in the scope of the model, and I wanted to update it inside the subscribe to, well, I'm basically making a mistake. I shouldn't be doing that. I should put that variable in the state. So we always have a consistent state. Finally, we reach the view, and here we're using compose because I can just say it's reactive and binds perfect with MVI. We have a composable function, and it takes an input the model based on some states and intent. We give it to this function of our library, remember MVI component, which returns a pair of the current state and a lambda function on intent. The state, you can imagine what it is. We can use it to render our UI using the data that's stored in state. And the on intent, I'm going to explain very soon. But what is, remember MVI component doing under the hoods? It's creating a flow of intents on which we can send more intents through a lambda function. And this, remember MVI component, it's also calling the famous subscribe to function that we see in the model, passing the flow of intents and getting a state flow. And then what we have to do is just collecting the state. But remember, MVI component is doing that for us. So we just get the state. That's it. So thanks to the lambda function on intent, we can transform the compose actions, which are listed lower in the other private fun. We can transform those compose functions in a flow of intents. And that was basically it. So let's see, what did we do? We've seen an example on how to define the intentions of the user with our library. We define states. How to update the states with the reducers. So we define the reducers. And then when, where we use these reducers and when in our model, and how to react to our intents. And lastly, we connected the model to and intents to our UI. I don't know if you ever searched, but there are quite a lot of MVI libraries on GitHub. And why are we doing something? Why are we making something again from a new? Well, because we simply couldn't find one library that was easy to start working with. It was like a library that was lightweight and would cover enough use cases. We couldn't find that. So, you know what? Let's do it from the beginning. Giovanni thought of that. And like, okay, from the beginning. So here are some pros of our library. The state machine is built on Kotlin Flow to handle and store state changes. We've seen that. We use reactive entities for both states and intents. We have hopefully a clear domain language with a few core directives that are open to customization. And the code is written, the code that you're gonna hopefully write with the library is easily testable because it's based on flows. So for example, you could use the library Turbine. And it's lightweight because there aren't that many files in the library, actually. If you see the GitHub repositories, there aren't that many. Well, what's next? Actually, we still need to publish the first public release of the library. It's going to happen very soon, like 10 days, hopefully. We want to migrate the library to Kotlin with multi-platform. We would like to add more DSL functions to cover even more use cases and write more documentation because, it's never enough. Well, guess what? The library is actually in production. We use it in our app. Matteo works for Conio. And it works. Yeah, it does. So there you go. It's in production, but it's still not publicly released. But there's the GitHub repo, so if you wanna give it a look, you can scan the QR codes or just type it down the old-fashioned way. And yeah, that's it. If there's any question, yes.